All right, welcome in. Today, we're diving into biomedical engineering, the field that's basically building the future of healthcare. And you're in the right spot if you want to go beyond just the surface level. We're going to really uncover what makes this field tick.
Yeah, way cooler than just like the first thing you think of?
Exactly. Forget just microscopes and lab coats. We're talking about real innovation here.
Cutting edge tech, life-changing solutions. We're going to give you a glimpse into the future of healthcare.
Love it. And our roadmap for this deep dive, RoleCatcher's Career Guide. They've done a great job laying out what this field is all about. They call biomedical engineers the bridge between biology and engineering, which, okay, that makes sense, but what does that actually look like, in practice?
Okay, so picture this. You're taking the principles of engineering, like mechanics, electronics, you name it, even chemical processes, and applying it all to the complexities of the human body. That's biomedical engineering in a nutshell.
Okay, so it's more than just designing those super cool, futuristic medical devices you always hear about.
Oh yeah, way more. Don't get me wrong, that's definitely a part of it. But biomedical engineering is also in everything from improving the medications we already use to developing entirely new tissue treatments. I mean, they're tackling some of the biggest medical challenges head on.
I'm seeing that. RoleCatcher mentions improving conventional medications specifically. Honestly, at first glance, that sounded kind of simple to me, like just tweaking a recipe or something. What makes that so impactful?
Well, think of it this way. It's about making the meds we already depend on even better. Even a small change to how a drug is delivered can make it more effective, reduce side effects. Maybe it helps people access it who couldn't before. And biomedical engineers are working at the nano level to make this happen.
That's actually really cool. Now that you mention it, I remember reading about microfluidic devices, like those tiny things used for drug delivery. Is that what you're talking
And
about?
perfect example. These devices are incredibly precise. We're talking personalized dosages and targeted delivery to minimize damage to healthy tissue.
So it's about maximizing the good while minimizing the bad, basically.
Exactly. And it's not just about making something new from scratch. A lot of it is about refining and improving what we already have. That's a huge part of what these engineers do.
Okay, so now I'm picturing these biomedical masterminds hunkered down in labs, surrounded by bubbling beakers, equations scribbled everywhere. Am I close?
You're getting warmer. Labs and research facilities, those are definitely common spots to find biomedical engineers. But it's not all test tubes and microscopes. They could be in a manufacturing plant, making sure medical devices are being made to the highest standard, or even in an office, collaborating on designs, analyzing data, or working through all the regulatory stuff.
Speaking of collaboration, the guides stress how team-oriented this field is. Sounds like you need to be a bit of a people person on top of all that scientific brain power.
100%. Communication is key. You're constantly interacting with a bunch of different people, other engineers, scientists, healthcare professionals. You even have regulatory agencies in the mix. Being able to break down those complex ideas so everyone understands is super important. That and working well in a team, building relationships, those are must-haves.
So it's not all eureka moments and groundbreaking discoveries then. Sounds like there are some real challenges and maybe even some less than glamorous tasks involved.
Let's just say, yeah, it's not always smooth sailing. The guide mentions working with hazardous materials, especially in those lab and manufacturing settings I mentioned.
Makes sense. There must be some serious protocols in place to keep everyone safe.
Oh, absolutely. You're dealing with people's health here. Meticulousness and sticking to those safety standards, that's non-negotiable. High stakes, but incredibly rewarding work when you think about it. I did notice the guide mentions high job satisfaction alongside those intense work hours. I guess that comes with the territory of, pushing the boundaries of what's possible in medicine.
Yeah, no question. It's demanding, but there's just this huge sense of purpose that comes with it?
I get that. The guide uses the phrase high level of responsibility, and that really resonated with me. This isn't just a job, it's about impacting people's lives, like really directly.
100%. The technologies these engineers help create, they have the potential to improve and even save countless lives. That's a lot of weight, for sure, but it's also what makes it so motivating.
It's like you have the power to change the world for the better.
Yeah, pretty incredible when you think about it like that.
So let's talk about the actual journey of becoming a biomedical engineer. RoleCatcher outlines different stages, starting with like fresh out of university or a junior biomedical engineer. What are those grads actually doing day to day out in the real world?
A lot of learning the ropes. Getting their hands dirty, soaking up everything they can from the more experienced engineers.
Like an apprenticeship for the future of healthcare. Pretty cool.
Exactly. The guide talks about them working closely with those senior engineers.
Yeah.
They're helping to design and develop medical devices and equipment. So it could be research, data analysis, even troubleshooting. It's all about getting that real-world experience.
And probably a fair amount of coffee runs thrown in there, too.
Oh, I'm sure. But hey, even those little tasks, they're all part of building a strong foundation. They're learning the ins and outs of the field. The technical side, the importance of teamwork, it all matters.
So you put in the time, you pay your dues, you graduate from junior to just plain biomedical engineer. What changes at that level?
Well, you get a lot more autonomy, more responsibility.
Yeah.
It's less about assisting and more about leading. You're making bigger decisions, really starting to have an impact on the field.
That's got to feel pretty exciting, but I imagine there's a whole new level of pressure, too.
Oh, for sure. The guide talks about them taking ownership of the entire design and development process. They're the ones doing feasibility studies, navigating the regulatory maze, even managing budgets and timelines. It's a lot.
So not just the science and tech anymore, they need some serious project management and leadership skills, too, huh?
You got it. It becomes a very multifaceted role. You need a whole toolbox of skills to succeed. And of course, as they gain more experience, they might even start mentoring those junior engineers coming up behind them, passing the torch to the next generation.
I like that. A cycle of innovation. It's pretty cool.
Mhm.
So what about those who really rise to the top? What does it take to become a senior biomedical engineer?
At that point, you're talking about true leaders in their field. And I don't just mean leading projects. I mean leading entire teams of super talented engineers. You're fostering collaboration. You're pushing the boundaries of what's possible in biomedical engineering.
So at that level, their work is impacting the direction of entire departments, maybe even whole organizations, right?
Absolutely. They're setting the vision, finding new avenues for innovation, making sure their teams have everything they need to be successful.
That sounds like an amazing challenge. And incredibly rewarding, too, I'd imagine.
It definitely is. They also tend to be sought-after experts, consulting with healthcare professionals, presenting at big conferences, even weighing in on policy decisions related to medical technology. Their voices really matter.
They've become thought leaders in their own right. That's impressive.
It is. And then, for those who really want to aim for the top, there's the title of Principal Biomedical Engineer.
Okay, yeah, that's got a nice ring to it. What sets a principal biomedical engineer apart?
Well, they're not just leading a team anymore. They're shaping the strategic direction of an entire organization, maybe even the entire field as a whole. They've got that deep understanding, not just of the techie stuff, but the business side of things too. And they're using all of that to drive innovation and really make a difference in healthcare.
Wow. It's amazing to see how far someone could go in this field, starting as a junior engineer and potentially becoming a principal engineer, leading the charge in healthcare innovation. It's honestly pretty inspiring. But before we get ahead of ourselves, how does someone even get started on this journey? What kind of education background do you need to break into biomedical engineering?
Well, the guide really stresses having a strong foundation in STEM, science, technology, engineering, and math. That's super important.
So a natural curiosity for those subjects is a good place to start.
Oh, absolutely. For most aspiring biomedical engineers, they're going to be looking at getting a bachelor's degree. And you guessed it, in biomedical engineering. That gives them that solid understanding of the core principles and how to apply them.
Makes sense. But are there other paths people take to get into the field? Like, what about someone with a background in, say, mechanical engineering, but they discover this passion for using their skills in healthcare?
You're spot on, actually. The guide mentions related fields. So that could be mechanical, electrical, even chemical engineering, as long as you've got that strong foundation in biology too. And that's what I think is so cool about biomedical engineering. It really is interdisciplinary.
It's not a one-size-fits-all kind of field. There are many ways to get there, depending on your interests.
And that diversity of thought is really valuable. It brings together people with different backgrounds and different ways of approaching a problem.
Yeah.
And often, that's how you get the most innovative solutions.
That's a great point. So we've talked about the education, the career paths, but what about the job market itself? What's the outlook like for all these aspiring biomedical engineers out there?
Well, the good news is the field is only expected to grow. And that means more demand for skilled biomedical engineers.
That's awesome to hear. Okay, so with all this talk about innovation, about cutting-edge tech, I can't help but wonder about the ethical side of things too. What are your thoughts on that?
Oh, that's huge. And honestly, it's something that's top of mind for a lot of people in the field.
Mm.
The guide doesn't really get into it too deeply, but it's one thing to be able to build something amazing, but making sure it's used responsibly, ethically, that's a whole other ballgame.
Totally. So, as biomedical engineers are pushing those boundaries, what are some of the big questions they're grappling with?
Well, you've got patient safety, of course, data privacy, even just the impact of all these advancements on society. There are no easy answers to these questions either.
Yeah, those are some big picture issues, and I bet those conversations are happening more and more as the technology just keeps accelerating.
Absolutely. And it's not just about talking about it. It's about actually building those ethical considerations into every single step, from design to development. You got to think about the potential consequences of what you're creating, good and bad. And patient well-being, that has to be the top priority.
So it's more than just being brilliant in science and engineering. You need that sense of responsibility, too. You got to be thinking about the impact of your work.
Exactly.
Yeah.
And honestly, that's what I think makes this field so interesting. It's not just about the tech itself, it's about the people it impacts. It's about using your knowledge to make the world a better place.
I love that. It sounds like biomedical engineering is more than a career. It's almost like a calling. So for anyone listening who feels that pull, that desire to use their talents in healthcare, what advice would you give them? What do they need to know if they're just starting to explore biomedical engineering?
I'd say never lose that curiosity. Ask questions, even the ones you think might be silly. Don't take anything for granted. And keep learning, always. This field moves so fast, you got to be hungry for new information.
Love that. And don't be afraid to reach out to people already doing the work. I'm sure they're full of great advice and would be happy to share their experiences.
Totally. Networking is huge. Go to conferences, join professional groups, connect with people online. You never know where those connections might lead.
Because sometimes those groundbreaking innovations come from the most unexpected places, right? And just being willing to collaborate and share ideas.
100%. So yeah, be open to new possibilities, get comfortable working with others, and never, ever underestimate the impact you can have.
So well said. This has been such an amazing dive into biomedical engineering. It's clear this field is not just about building the future of healthcare, but really it's about pushing the boundaries of what we're capable of as humans.
I couldn't agree more. It's really an honor to be a part of it all.
For sure. And a huge thank you to RoleCatcher for putting together their career guide. It's an amazing resource for anyone interested in learning more about this field. Definitely check out their website if you want to go deeper. And to everyone listening, we'll catch you on the next deep dive where we'll break down another fascinating topic. Until then, keep those brains engaged. Keep exploring, keep learning, and keep asking the big questions.